guys, and welcome back to a new Compose video. In this video, you will learn how you can work with custom navigation arguments with the new navigation Compose framework, so the type-safe way of navigating. So specifically, you will learn how you can pass custom data classes as a navigation argument from one screen to another, as well as enum values. So you can see we have a list of some dogs. Each dog is in the end a data class in our code we will create, consisting of an ID and a name and an optional breed size. And if we then click on one of these dogs, like a beagle, then we will get to our second screen, which will display all that data, and that will be passed as a navigation argument. Before we get started with this, just a little disclaimer that I would not recommend to do this with potentially large objects, since the way this works internally is that we take a value, we serialize it, we save it in a bundle, but there is a maximum size of elements we can save in a bundle. So for example, if you have a list screen where you load a bunch of entries from your local database and you then want to have a detail screen after clicking one of these list items, then I would much rather recommend you to just pass the ID of the item you clicked on and then reload that from the database on that detail screen. The approach with passing the whole data class as a navigation argument that I will show you here, I would only recommend if you really work with smaller bundle data where you know it won't exceed a certain size. So for example, if your data class contains lists, then I would be very careful with that, even though this approach would support that. All right, in order to get started, the first thing you need to do is you need to add the navigation compose dependency as well as the Kotlin serialization plugin, since that is the way, or that is the library we'll use to actually serialize our data classes to JSON and from JSON during the navigation. So I added this serialization Gradle plugin. I added these two dependencies here. You can of course find the final code down below on my GitHub and the version here for navigation compose. Then just make sure that in your build.gradle app file, you add this serialization Gradle plugin here to your plugins block. And lastly, down here, you make sure to add these two dependencies for compose navigation and Kotlin X serialization to your dependencies block. And then you are ready to use what we need. First of all, how do we get started? Let's minimize this here. Let's open this instead. Let's first of all create our class that we actually want to serialize and pass from one screen to another. That will just be a normal dog class, as I promised. Can be a data class. And since we want to serialize this with Kotlin X serialization, we need to annotate this class with @serializable, like this. Then we can define what makes a dog. In our case, as I said, we have an ID, or we can make this an integer instead to also have some different types of attributes here. And we have a name for each dog. And another thing I would like to show how we can pass this as a navigation argument, which is very common, is when we have enum classes. So enum class, let's call it breed size. And we have a small, a medium, and large sizes. So depending on how large that specific dog breed is, we can assign a certain breed size. Normally, I would put this as an attribute here to our dog class, but I want to also show you how you can pass just single enum values as a navigation argument in Compose navigation. But you could also just make that an attribute here. Say, okay, you have a breed size, and then make that part of the dog class, and that will also work just fine. All right, next up, we can come to our navigation graph, where we just define which screens we have, what types of navigation arguments these expect, and in which case we want to navigate to which screen. Let's do that. Let's just put that in main activity here. In our scaffold, we have our navigation, nav host actually. We can define a nav controller up here, which allows us to navigate. We get that with remember nav controller. We can pass that in here, nav controller. We don't need to specify a graph, but we can rather specify the start destination. And here with this type-safe navigation approach, we actually need to define these routes, which were previously routes. You can see like a home string. We need to define these as actual classes or objects in Kotlin. So this could look like this, that we have a data class for our dog list screen or dog list route, which actually does not take any navigation arguments, since that's the initial screen where we get to. So we don't need to make this a data class that has a real constructor, but we can rather make it a data object without a constructor. We still need to annotate this with serializable to make this work with this new type-safe approach. And then we can say, okay, we have a data class now for our second screen, which expects these specific arguments. Dog detail route, for example, which will now contain the actual arguments that we expect to pass from our list screen to our detail screen. So on the one hand, that is an instance here. It already suggests that. An instance of our dog, the more complex type we now want to pass. And that is an instance of our breed size, so the enum value that we want to pass. We also want to make this as serializable. And then we can start using these two routes that we've defined to define the start destination, which in this case will be our dog list route. And then we can open this navigation builder block. So on the one hand, we have a composable block here, so a screen for our dog list route. And we have a composable screen for our dog detail route. And in here, in the dog detail route, we can then easily fetch this object in a type-safe way by just saying, okay, we have our arguments, which we get from the current backstack entry, so it.toRoute, and we need to convert this to our dog detail route. And then the navigation framework will try to parse our navigation arguments again into this data class, dog detail route, which contains our desired arguments. However, if we would run this right now, even if we would have code to navigate, then that wouldn't work, because by default, there are just some values that, or types of values that the composed navigation framework supports. Like, of course, all these primitive types, passing integers, strings, but there are certain limits, like passing custom data classes, because for these types of classes, the navigation framework doesn't really know how to serialize and deserialize that. So we have to define that. And the way we define that is with a so-called custom NavType. That is nothing else than a class that lets us define, okay, this is how we want to serialize this dog instance to a format that the navigation compose framework understands, and this is how we can then deserialize that object again. So here in our root package, we can just create a new file. Let's call that, we can make that an object called custom NavType, or let's call it custom NavType and make that an object. And in here, we then create our dog type. So we have a val dog type that's equal to an anonymous class, so an object of type NavType of type dog. So we define our own custom NavType for our dog instance, or for any type of dog instance. This does need a constructor where we need to define whether we want to allow passing null values here. So is not allowed. Well, however you want to use this instance or this NavType in your app. Let's say we don't allow that here. And then in here, we can hit Command I to override these three functions. Now, I think these functions actually make these custom NavTypes a bit hard to understand, because essentially for composed navigation, we need one more function which it doesn't force us to override. And that is, let's put this down here, that is serialize as a value, which by default just, if we take a look here in the super function, which by default just relates to value.toString, so it would convert our dog instance to a string. But that is not really a presentation we can then use to deserialize that dog out of that again. So we want to override this, which it allows us to do since it's open, with a custom implementation that really takes this dog instance and serializes it as a JSON string. But what I personally find a bit unclear about these custom NavTypes is that they seem to work with two different serialization mechanisms. So on the one hand, we have a serialize as value and parse value. So this one serializes our dog instance here as a string, and this parse value is the counterpart of that, which takes in the string again and gives us our dog. But then on the other hand, we also have this put and get function, which in the end do the same. They also serialize stuff, but work with a bundle. I think this is for compatibility reasons to also work with the fragment navigation, for example, but I might be wrong with that. We definitely have to implement both these functions to also properly make them work for compose. And I think it might be related to that this serializes the value to what it should pass as the route. So what kind of value it should really put in the string route that it will translate to, since compose navigation works with these routes, but fragment navigation doesn't. So these two might only be necessary for compose, but all these are necessary if you want to have a NavType that works for all different navigation approaches. So what we want to do here is, let's start with the serialize as value function. We now want to take our dog instance, this value, and serialize this to JSON in the end. But one more thing to consider here is, if we again take a look into this serialize as value function, the final output should be encoded with URI.encode. And the reason is that the final output of this will be put into our string route, which is in the end nothing else than a URL, or at least very comparable to that. And for URLs, we do the same. We also have to encode these. For example, there are certain characters we don't want to have exactly like that in the URL, like a space character, but we rather encode it to some kind of percentage something character sequence, so we don't have any issues parsing. So in here, we not only want to say JSON.encode to string, but we want to say URI.encode. And in here, we put in our JSON.encode to string, pass in our value, so our dog instance, alt enter to import JSON, and then this function is already implemented. As I said, this parse value is the counterpart of this. We then take the value, now read the underlying dog from our JSON value again, and then return that here. So here we can say JSON, actually return JSON that decode from string. And in here we then say URI.decode again to take our encoded URI to decode it and then pass in the value. For our other two functions, for the put function, we now get an instance of a dog, we get a specific key, and we now need to implement the functionality to put both these in a bundle, or we can also use JSON. So here we want to say bundle.putString. So we want to put our JSON string at the key of key, which we get passed here. And the value is just JSON.encode string, and we pass in our value. Here, I don't think encoding this to a URI is necessary since bundles work differently than URLs. So here we don't really need to have that as a URL format. So we can go up here and also read this again as a dog. So we take our bundle, we return bundle.getString at the key, and this whole thing we actually want to decode from JSON. So JSON decode from string and then have this bundle.getString. And in case that is null for whatever reason, we also want to return a null instance of dog. And now that we have this custom dog type, we can take this, go to our main activity, and here for the screen where we expect the type of this argument, we still need to introduce our composable here to that custom NavType. Otherwise, it won't know that. You can see it's unused by default. So we have to introduce it to our composable in some way. And we do that with type map by defining all those custom types we might want to have here for this dog detail route, which is really nothing else than just a normal map of, where we map a specific type of, in this case, a type of dog, to our custom NavType.dogType, so to the corresponding navigation type that fits to that class. Same goes for our enum. There is already an enum navigation type, but we still have to define that we actually want to use this specific breed size class as an enum value here. So we have type of, breed size, and we map that to NavType.enum type of type breed size, and in here we also need to specify the breed size class Java, and then we actually don't need this. All right, so the last thing we now need to set up is our very basic screen structure, so that we have a list of some sample dogs on our list screen, and then that we can display these arguments on our second screen. Let's create a separate screen here in our root package called dog list screen, which is a new file. Make a composable in here, call this dog list screen, and let's keep this super simple. I won't even pass in a modifier here, but rather just provide a lambda on dog click. So when we click on a specific dog, we get the dog and the breed size, which again, you could of course combine into the single dog class, but I just wanted to show you how you can also pass custom enums without having them be part of such a serialized class. And then here we just have a lazy column that we assign a modifier of modifier fill max size 4, so we just fill the whole screen size, and in there we might have a list of items where we now need a sample list of a few dogs. I will just paste this here. You can also copy paste this from my GitHub if you want, or you just create your own list of your own favorite dogs. So just a few sample data dogs, which we then have here in our items block. Loop over these. We need to make sure that we have the right import. So items, make sure to import this list import. For some reason it complains. All right, because that's still a map that maps each dog to a breed size. So we can just say sample data dogs.keys and convert that to a list. So each key is a single dog, and then we get a reference here to each dog, which you can then use to just display a simple text or so. We say, okay, dog.name. We can just say dog.toString, so we see the whole object actually. And we say, okay, modifier is modifier fill max width for this one. And we give it some padding of 16 dp, for example. If we click such a dog, then we trigger our onDogClick function with our dog as the first parameter. And the breed size is just our sample data dogs at the key of our specific dog. We can assert this is not null, since we know if this dog exists, then at this key, there will definitely also be a certain breed size. It's really just simplified code, so I can show you how we can pass navigation arguments. So we can now go ahead and create our detail screen as well. So new file, dog detail screen, make that a file, composable, dog detail screen, which will now take in, on the one hand, our dog instance, and the breed size that belongs to that. And here we can really just have a box that centers our content with a modifier of fill max size. We can say content alignment is center. And then in here, we can have a text composable, which really just displays, let's also just say, okay, dog.toString, or we maybe format that a bit better. We can say, okay, dog.name with the ID of dog.id has the breed size, and we pass in our breed size. And I think that is already enough for this dog detail screen. So we can go back to main activity, link these screens here to our composables in the nav host. So we have a dog list screen. I am always a friend of naming the lambdas here. Otherwise it would look like we put composable content in there if we would use the trailing lambda. So here, when we click on a dog, we get the dog reference, we get the breed size, and then we can say, okay, we have our dog list screen. Not dog list screen, we have our nav controller and navigate, of course, with this information. We want to navigate to a certain route of type T here, and the route will be our dog detail route, of course. So we have our dog detail route, which we can now construct with the dog being equal to dog and the breed size being equal to breed size. On our second screen on the detail route, we can now construct our dog detail route, dog detail screen, and we pass in our arguments.dog for the dog and the arguments.breed size for the breed size. And I think that should be it. We could, of course, make use of this inner padding here to make sure everything is properly aligned by giving this modifier of padding, passing in the inner padding of our scaffold. And then we can launch this because I think we are ready to test what we've written so far. There we go. We do see all of our dogs here. Looks a little bit different than on my previous demo because we just converted each dog class to a string here, and then it will look like this. Let's try that with a German Shepherd. We click on that, and then we do get the text here where we get the name of the dog, we get the ID and the breed size. So passing all these arguments as a custom data class works just fine. And also if you end up deciding to put this breed size instance here inside the dog class, then that will work just fine, which I would actually find more intuitive here since each dog has exactly one breed size, obviously. But very often you also just want to pass custom enum arguments, which is why I wanted to show you that as well. Down below, you will find a link leading to more advanced Android premium courses, which all also cover Jetpack Compose. So if you want to dive deeper into that topic, then check them out. And other than that, thanks so much for watching this video. I will see you back in the next one. Bye-bye.